So thank you once again, and it's an exciting topic. As Upul mentioned, there's also a bit of hype associated with the excitement. So let's try to decipher or demystify what generative AI capabilities are and how that can be useful in research and practice, theory and applications. So I'd like to hear from the audience as well in the different areas of work, if it's in electrical engineering or electronics engineering or computer systems, or if it's purely in AI that you work across, and also maybe towards the end of the session, the Q&A, we can discuss different pathways and opportunities, either for the current work you're doing or potentially new areas of study and so on. So on that note, I will start. So it's customary for us in Australia to acknowledge country. So in the spirit of reconciliation, the Trobe University acknowledges the traditional custodians of country throughout Australia and their connections to land, sea, and community. We pay our respect to their elders past and present and extend that respect to all Aboriginal and Torres Strait Islander peoples today. And then thank you again, Upul, for your contribution and support to our generative AI hackathon. So it's associated with this topic. We've had a record number of submissions to the 2024 IES Generative AI hackathon. And we're looking forward to many exciting and innovative developments through the hackathon, which we will progress towards the flagship conference of the Industrial Electronics Society, which I will talk about later if we have a bit of time, the ICON. And this year it's the 50th rendition of the ICON, and that it's been held in Chicago. So we're looking forward to the outcomes of the Generative AI hackathon, and thank you again, Upul, for your support and contribution. All right, so this is just to add to Upul's very colorful introduction. Thank you. Just the center that I work in. So we do research, applications, teaching, as well as building different kinds of AI systems and solutions, from pure algorithmic to application-focused research. But not just the academic research, we also push the boundaries of building these as systems or platforms that can be deployed. And that is also funded by industry. So this is the ecosystem of research in Australia and most of the OECD, I believe, where universities are encouraged or, well, forced sometimes to make sure the research that they conduct has a practical application, a practical value to the taxpayer dollar that's spent on in the public university system, so that the research is not just purely theoretical or not very useful, but it has to have some application. And the research portfolio in our university is research and industry engagements. So not just the research, but also engage industry and try to understand their problems and solve them. So this is it's an equally important part to the academic research component, and that's something we do. So theoretical and applied research in AI and analytics, automation, ethics. So from data, the story begins with data and generally ends with ethics. And then building these as solutions and applications, and also teaching, so things like micro-credentials, short courses, consultancy. So that's our email address and a bit of information. If you're on LinkedIn, maybe you can give us start following us, a bit of a plug there. So just a brief about me. So just to add a bit of credibility to what Upul has already said, so that you trust what I say to some extent. So I've done a few things, and in terms of academic research, I am an associate editor of 4 journals. So I see a broad landscape of the different kinds of AI research that is being submitted to these journals. And also to speak to my currency in AI, I supervise close to 10 PhDs, as main supervisor 8 and as co-supervisor some others, which also we continuously try to push the boundary of AI research. And in the IEEE, as Upul mentioned, I hold a few officers. I was also had the privilege or the pain, anyone who's organized a conference would understand this, of being lead general chair of an international conference sponsored by the IEEE in Melbourne, and also program co-chair. So potentially these are positions of interest to some of you, so we can have a chat about these as we progress in the session. And of course, research publications and research funding are further highlights there. Besides research and industry engagement, we are also encouraged or pushed to increase community engagement or public awareness. And then given the nature of AI, it's been resourceful for academics or experts to present their positions, viewpoints in the media. So I've been quoted a few times, the national news, the ABC News, and a few other places. So this also adds to your visibility, and also it promotes the understanding of AI, and it's a bit of public service as well. All right, so on to more interesting topics now that I've maybe established my credibility. So we start with AI definitions. I think some of you might be familiar, given that I don't have prior knowledge of who's in the audience. We'll just skim through these anyway. A bit of an AI life cycle. So this is based on a paper I've published. It's been cited, so I'm assuming it's good, and I don't mind further citations. Another plug there. Yeah, I think they'll be useful to understand how to build an AI solution. If you're starting to build, or maybe you can improve your current practice based on what we have documented there. And then generative AI, some Gen AI examples in the mainstream, and then we'll transition into some of the, or all of the IES topics of interest. And I might even showcase what's on the IES website, so you know how to navigate that space. And then the art of the possible, topics of interest where there's potential for good novel research, not just the theoretical, but also the applied research. And also finally, we'll wrap up with how you might get started if you're new to AI and generative AI, but you have a strong domain expertise. So for example, if your expertise is in energy systems, then how do you start to understand the value and the contribution of AI? So we'll look at some getting started material. So AI has been around for a long time, more than 60 years. And the first definition by Marvin Minsky, so he was one of the first people in that 1956 workshop to coin the term. But he defined AI separately to that. This is his definition: science and technology of making machines do things that would require intelligence if done by humans. I quite like this definition, although there's been hundreds of definitions since then. And there's a tongue-in-cheek bit of a joke that there are as many definitions of AI as there are experts. So this definition is still valid, and that's the idealistic version of AI, where the machines can do things that require intelligence if humans were to do this. And that is a benchmark, or that is an evaluation metric for anything that we might call AI. So if you want to distinguish between non-AI, so say standard automation, and what is intelligent, then if you push the human into the loop, then can the human still perform the same task without intelligence? So sequential tasks, repetitive tasks are more automation versus intelligence. So that's the distinguishing point. But interestingly, the second dot point there is quite recent. I think it was November or October. So it's OECD, the Organization for Economic Cooperation and Development, so which is basically all the developed countries in the world. They have groups of experts, and they came together to try and redefine AI to suit the nature of recent developments, specifically generative AI, which started off in late 2022. And as you can see how sort of complicated that definition is compared to the first one. And that is the true nature of AI. It is an evolving beast, if you like, and it has many different capabilities that we discover or uncover maybe 5 years after we've implemented and deployed it. And this is a function of intelligence, because we cannot really predict or constrain true intelligence or any form of intelligence, really. And that's why it becomes difficult to manage AI or define AI or govern AI or regulate AI. So after they published this, interestingly, they had to justify this definition, which led to all these crosses and highlights and text in bold. One person who was in this group was Stuart Russell. If anyone studied AI, one of the textbooks, or the first textbooks I used to study from, Peter Norvig and Stuart Russell, and that's been a bit of a standard textbook in any AI course. So he was part of this expert group for defining this. So I'm not going to repeat that definition, but you can find this online as well. You can see how much, how loaded this definition is. It's not just one function. There are many different capabilities of AI, and also there is a bit of a disclaimer towards the end. So different AI systems can vary in their levels of autonomy and adaptiveness after deployment. So sort of a buyer beware, we are hands off. It can change its behavior after it's deployed. We don't say that about any other system, and this is because there is an element of intelligence. So in some audiences or different people, different groups of individuals or communities, there is usually a confusion between AI and machine learning. Sometimes it's in the classroom as well. Presumably this audience does not have that confusion, but just for clarity, machine learning is one form of AI, whereas if you look at the last point, there are many forms of intelligence. So it's not just learning, there's perception, reasoning, memory, recall, planning, reflection, expression, and so on. So we don't have artificial systems for these, artificial techniques for these, but we have really good and probably better than the human learning system. And that's why machine learning is the most widely used method of building or generating an intelligence. So you learn from data to become intelligent. So machine learning is one method to achieve AI, but there are other methods, and things like reasoning perception have been tried in the past, but they haven't been as successful as machine learning. So this is Tom Mitchell, is also quite famous, high-profile researcher. That's his definition, and this is another one, I think, also from Tom. You can later figure out what the E, the T, and the P are. If you've built some classification or prediction models, I'll leave that with you. So that's the distinction between the two. So now we have a new kid in the block, which is generative AI. And then generative AI is kind of loosely defined still, but most people, most researchers, experts agree that it is an AI that generates new content. And this new content is complex. It's good. It's human-like. It's precise. It's accurate. And it's seemingly meaningful. So if you think of how machines learn through data and humans learn through knowledge of the world or experience of the world, physical experience, but also from textbooks where it's encoded. So the AI only has this encoded knowledge in text, and that's how we have these large models or text or images. So that is the difference in how they learn, and that difference travels with the AI into what it can generate. So new content that was not in the training data set. So this is the significant difference between conventional AI. Now we call it conventional, but before generative AI, it was good AI or narrow AI, is where it's mostly based on the training data set, whereas generative AI is not based on a training data set. So that's where the complexity is, because that's how humans will create new things, innovation, new ideas, new images, creativity. So all of that is because of that, the nature of human intelligence. So now, because of generative AI, we have a different word for what is old AI, which is ANI, so artificial narrow intelligence is task-oriented. So it takes one of four. I have this on the next slide. So it's usually a prediction, a classification, and association or optimization. Whereas generative AI is none of these, and it's not a simulation because it creates new output. And that's why it's different to any of the AI we've had before. I think everyone had their own ChatGPT experience. So as you would have experienced, there is a new term for this content, AI-generated content. And more recently, if you saw Kate Middleton's photograph being doctored, there's potentially some bits of AI there. So that is also AI-generated content. And that is, besides the social or the governance problem of do we encourage AI-generated content, there's also the other challenges of detecting deep fakes or artificially created images, and also the copyrights associated with the training data used to develop AI that can generate those images. So why should we bother? Because AI has been around since 1956 or 68, and now suddenly it's become hype or very topical, and everyone's interested in this. Firstly, because AI learns faster than humans, and if you throw any metric at this, AI will come out the champion of learning faster, because it learns 1 billion data points in a matter of weeks or months or a couple of days even, given sufficient computing. Whereas if a human or even a group of humans were asked to read 1 billion rows of data, text, images, we would just remember the most recent 5 or 10 things, not 1 billion records. So by any measure of performance, this learning algorithm, which is typically based on backpropagation, or a variant of this, the transformer also has origins in backpropagation, is a lot more efficient in learning. So if you think of just the function of learning, AI can learn a lot faster than humans, because humans will take 12 years and plus to understand how the world works. And even then, we don't have 1 billion records being learned. We have a lot of abstraction going on. So that's the main difference. And also now the AI is simple and effective. If we discussed this 10 years ago, it wasn't. It takes a lot of effort to build it and also then understand it. And also AI is cheaper than it used to be. So case in point is ChatGPT, where they just released it free of charge for the entire world. And they're probably spending a lot of money on the processing computing, unless they have optimized it by now. And because it's cheap, then many people can use it at the same time. And that means, if you're not using it, your competitors are using it. And that means you will be at a disadvantage. It's also becoming a general purpose technology. And that's things like the computer, the internet, where it's had a significant transformative effect across the entire economy. That last dot point speaks to this. So some early estimates from people working in workforce and economics of the workforce, 80% of the workforce could have at least 10% of their work automated. So this This is, well, obviously bad news for the workforce, because we have to retrain, reskill, and potentially there can be technological unemployment. But on the other hand, it is an opportunity to improve the quality of the services and the products that we provide as organizations or companies, and also consume as clients and customers at the other end of that. So there's good and bad here, and it's also called a digital transformation with intelligence. So these are some of the other stuff that has happened in the past, and comparatively, intelligence is not constrained like any of these inventions. Intelligence is unpredictable, but also quite innovative and creative because of that. Also, late last year, we had AGI being defined by Google DeepMind. So AGI is artificial general intelligence, which is the next stage. So in some ways, the creation or the invention of generative AI is signaling that we might have AGI. Pick a number, really, but some estimates are in the next 5 years, there'll be light versions of AGI. It's between 5 and 30. So by 30, in the next 30 years, there'll be a quite advanced version of AGI. Speaking of which, okay, I'm going to skip a couple of slides. So this is the spectrum of AI. So we start with artificial narrow intelligence, which is usually 4 capabilities: prediction, classification, association, optimization. I'll come back to this. If you see in the image, face detection is a narrow intelligence. It's task-oriented. It has a specific goal that needs to be achieved. Are there faces in this image? And draw a bounding box where the faces are. The same with human pose recognition, what you see here. And then you have a combination of this and others in things like self-drive cars, which is commonplace across many cars these days, where it will detect hazards or people or other cars in the vicinity. Then what's happening now is generative AI, where we have new, complex, meaningful output generated by the AI. So it's not a prediction, classification, association, optimization. So many examples, and this is just a funny example. So Santa Claus taking a selfie in the midst of hurricane. So this sort of image is unlikely you can find this on the internet unless it's created. But then the AI is smart enough to figure out the core elements of that and put that together. So that's what we have now, and we can create many of these using DALL-E or Stable Diffusion and so on. Here, AGI is the next phase, where human equivalent intelligence, it's not just for one task, for many tasks. And there are many tests for this, highly theoretical, that people in the past have proposed and even currently. So one interesting test is the coffee test, or tea, is where pick a random house down a random street, and the AI or the robot with AI should walk into the house and figure out how to make coffee. So you have to figure out where the kitchen or the pantry is, and then figure out where the different containers are and how to make coffee, and then have to find the mug and so on. So that is general intelligence. We're not there yet, but that's in the horizon, because people are starting to define what it will look like. And then finally, we have super intelligence that exceeds human intelligence. And this is very much sci-fi. If you think of Skynet or The Matrix or iRobot, it's at that level, which is most likely not in our lifetime. And hopefully we have a lot of good regulation before that happens. So I go back a couple of slides to talk about how do we use AI. So these are the conventional AI capabilities: prediction, classification, association, optimization, and obviously the generative AI. So this paper is from 2022, before generative AI broke into the scene. It's an open source paper, so you can read that. That's a QR code for it. So the capabilities and the algorithms and the applications. So I've got quite mainstream applications, not so much industrial. So a prediction is a numerical prediction, and things like demand prediction or load forecasting, demand side renewables forecasting, if it's energy, if it's just the standard business revenue forecasting, weather forecasting in some ways, whether it's a complex system, so we try not to forecast because the error will increase in magnitude. And then these are the algorithms, and the algorithms have significant overlap. So, for example, you probably heard of the phrase, when in doubt, use XGBoost. So it's used widely in prediction classification problems. So second capability is classification, and that's when you want to classify, is it spam or not spam? So if it's like email, fraud or not fraud, anomaly or not anomaly. And that's a very common application in industrial electronics topics of interest. These are the algorithms, and then association is grouping. So are there similar groups, which is an unsupervised learning technique. So recommender system, segmentation, topics, if it's text. And then optimization is given certain conditions, what's the best configuration? So you've probably seen the traveling salesman type of problem. Extension of that is scheduling, control systems, utilization, resource utilization, optimization, and those are some of the algorithms for that. So in the same article, I go into details about an AI lifecycle, so 19 steps, and there's quite descriptive level of information about the different steps. So you can also have a look at these, the full AI lifecycle in that article. All right, I don't see any questions, so I'll keep going. So now we just looked at some textbook examples, but how does it actually translate to real life benefit or practical value? So the best example, if you haven't heard of this before, for conventional AI or narrow intelligence is in healthcare, and this is saving lives or reducing the cost of healthcare. Or improving quality of life, is in cancer diagnosis or tumor detection. So the same concept or same algorithms as face detection, which is replace faces in the training data set with tumors, and lots of tumor examples. So the most common cancers are prostate, breast, bowel, melanoma, lung cancer. So about 60% of all cancers. And these can be better treated through early detection. So early detection is trying to figure out, is there a tumor and how much of a certain organ is cancerous or has the tumor. And then the next stage is managing it through medication or radiotherapy or removal. So different methods of finding the different imaging techniques, which are quite mature and advanced. And then so many different headlines of how AI is trying to detect cancer, early detection of cancer, and different companies building better AI for this diagnosis task. So these are some of the images. It probably looks familiar in terms of CT scans, MRI scans, and so on. This is an example of how it works. I won't get into details, but as you can see, the bounding box between a human radiologist and the AI is significant. So this means we are removing less healthy tissue and more tumor tissue compared to a human trying to detect where the tumor is. So this bounding box is millimeters or slightly larger, but that is a significant difference because the organ is not, it's within the centimeters or maybe even in the millimeters of dimensions. And that means that difference really matters for recovery, for quality of life, for remission, and so on. And as you can see, lots of different tools that are quite mature for detection. So this is good, stable AI. The moment research becomes commercially viable, and there is a number of tools, providers of commercial AI, it is good AI. So that's conventional AI or non-generative AI. This is generative AI in help in the form of Copilot, which is headlining these days with Microsoft's release of Copilot. And then Bing Chat, the Microsoft Edge browser also has a Copilot. So these are called AI assistants, co-intelligence, scribe, intern, etc. And this is an interesting article where, which speaks to the challenge really. At the same time, they've laid off 75,000 workers. They also hired, or they also invested in a new AI assistant tool to improve the quality of care, or to reduce the number of jobs they have to fund, or on the flip side, to improve the quality of care. So this Kaiser Permanente is a large chain of hospitals with over 300,000 staff, and that has to be a well-thought decision to invest in AI and also lay off staff. So this is a challenge that will now start appearing in more organizations in the future, and something as responsible engineers, practitioners, scientists, and especially aligning with the IEEE Code of Ethics that we have to be conscious about, and make sure any decisions that we take are ethical. So this is another example of generative AI education. You probably heard of the interest in, or the potential interest in having a personalized teacher for each student in the classroom. And this is what it looks like: a society of minds, or an army of bots that will translate the curriculum to you in different flavors. So you can have it in the style of Greta Thunberg, or Karl Marx, or Einstein, or Shakespeare, and so on. This is still, it hasn't been attempted yet. It is being discussed quite extensively, and Khan Academy, which is a free online, YouTube, it's on YouTube, it's a YouTube channel of different kinds of teaching material. The Khan Academy is trying out Khan Migo, which is a chatbot that is able to be personalized to suit the speed of learning and the level of prior knowledge of individual students. You've probably seen this, GPT-4 taking different kinds of exams, and pick an exam really, because an exam is a targeted problem or task. There's a well-defined type of answer to different kinds of queries, and that means the GPT can be fine-tuned a lot strongly to suit this kind of well-defined task. So it's a controlled environment. It's an exam. It's not an interview. It's not a discussion. It's not a presentation. Because an exam is a closed-loop system, we can fine-tune and make GPT-4 a lot smarter. So the difference between 3.5 and 4 is all of that in green, where the scores are quite high. And there are general practitioner, so medical examinations, chemistry examinations, and so on. So this is a power statement for OpenAI. How good is our AI? And that has really turned heads. A lot of people thinking about how to use AI to improve their organizational or industrial activities. So now we move on to more of the Gen AI capabilities, and the capabilities can change based on the modality of the data that is used in the training of the large model. So typically we have 4 modalities: text, video, image, and audio, and then there's also a fusion of these. In the quadrants, what you're seeing is the source data and the types of models used. For example, in text, we all know that ChatGPT or BERT, Llama, and Claude are text-based generative AI. The same goes for video and image. And then outside the quadrant, you can see the capabilities for those models. So if it's text, we have things like Q&A, classification, summarization, brainstorm, coding. If it's video, to generate the video, to animate the video, so rotoscoping, in-painting, post estimation, and so on. and the same goes for the other modalities. So this is a visual summary of the modalities, the models, and the capabilities. And now that we know in a summarized way that we know the capabilities of generative AI, the next step is to look at how they can be applied or built into industrial systems and solutions. So before that, we need to know how to access generative AI. So I think everyone's familiar with the most lightweight method of access, which is direct use through the web application or the smartphone application on the browser. So we write the prompt or the question, and then we receive an answer. Slightly more complex or more efficient is to use the API to access the generative AI model. So there's usually an API key that you have to pay a subscription, and then you get access. And then the next one up is a retrieval augmented generation. So generative AI by itself has a few challenges. It can make up wrong answers, and that's why I said seemingly meaningful. Sometimes the answers are not meaningful, and this is called AI hallucination. So if you have generation and retrieval together, so retrieval is knowledge retrieval, like from a database or document database. So you retrieve the content, and then you use that content to inform the generation or augment the generation. The terms describe themselves. Then you have less likelihood of inaccuracies, fallacies, errors, and so on. And then next level up is to fine tune or transfer learn, and that's when you have large enough data set to improve the focus of a large model towards a specific challenge or problem. So there's fine tuning and transfer learning. And then finally, the most complicated is to build your own generative AI model so that you can have a more novel or more personalized experience in terms of the applications you want to solve. But this is, there's a few challenges there, finding the right levels of processing computing power, collecting large enough data sets. So we're speaking in the billions. So not many people build their own AI models. Instead, the next step for more technical projects is to fine tune or transfer learn. All right, so if you go back to the lowest tier, direct use is called prompting or prompt engineering. I'm assuming that's a familiar term to most in the audience. So the structure of a prompt is to have a persona, the context, the outcome or action, and some style, format, parameters. So persona is that you want to give, you want the generative AI to create a level of expertise such as power systems researcher, smart grid researcher, smart cities researcher. So we write a little bit about the persona that they should take when responding to the question. And then the next prompt is we provide lots of context. So I want to know about smart grids in terms of renewables or in terms of transmission or distribution. And then what kind of outcome or action? Do I want a summary? Do I want dot points? Do I want a list of questions to ask a potential industry partner? And then some style formatting. How do I want to see the content being expressed in terms of scientific terminology, technical terminology, or corporate terminology? That's the style or the format. Okay, so prompting or prompt engineering is a science or an art onto itself. So I'm showing this is a recent prompt where it failed or got terribly confused, hallucinated. So this is ChatGPT Vision or GPT Vision. My first prompt was to generate an image of a living room without an elephant. And then obviously there is an elephant in there. And the second prompt was that I said that image contains an elephant. Can you please redraw one without an elephant? So if you see the pattern, across the two prompts, the word elephant repeats 3 times, and quite rightly or confusingly, there's 3 elephants in the second image. So this is the general limitation or weakness of generative AI, that it gets it wrong because it hasn't learned as humans do. So it's missed the word without. Instead, it's focused on elephant, and that's where the attention-based transformer architecture is at its worst. And also, it's looked at the two prompts, and it's seen the word elephant occurring thrice, and there's 3 elephants in the second image. So this is hallucination, and this is also a design flaw in how it learns, and that's why it cannot replicate human intelligence exactly as it is, because it does not learn the same way that we do. So prompt engineering is a skill, and it's something that you have to invest a bit of time in. So I've just given you some thought starters: persona, context, outcome, and style. And then there's lots of online material. I have a couple of links towards the end. So potentially you can have a look at these and explore these at your own time offline. All right, so now we know the story of generative AI fairly briefly, a concise version of generative AI. So now let's look at industrial electronic society. So the IES is one of the many societies in the IEEE, and the IES has about 11,000 members, so it's a medium-sized society, but it has good leaders, good people, self-promotion there, and also it has good strategy to invest in membership activities, technical activities, industry activities, and so on. So if you haven't seen the website or explored this, so this is the definition adopted by the IEEE. So creation, development, integration, sharing, and application. So lots of action verbs of the theory and applications. So both theory and application. And these are the areas of interest: electronics, control, communications, instrumentation, and computational intelligence. And usually the application area is in industrial or manufacturing systems and processes. And then now ends up with the IEEE vision for the benefit of humanity and the professions those people are involved in. So one challenge, if you've worked on electronic systems, industrial or otherwise, is that most of these systems are model-based and problem-oriented or problem-focused engineering solutions. So in that sort of setting, how do we bring an element of intelligence into this? So this is the challenge, because if you think of power systems, it's a controlled, it's a control solution. It has very specific parameters. If it's even a sub-physical system or an automated conveyor belt in a factory, a very specific goal to achieve, and that's it. It doesn't try to achieve anything beyond that. So this is a challenge, but also an opportunity, because we can now look at bringing more intelligence into these well-defined model-based problem-oriented systems and techniques, and try to expand their capabilities. So there's a few examples coming up that I speak to. But before that, the opportunity lies in the action verbs of design, develop, simulate, deploy, or standardize. So the creation, development, integration, sharing, and then these are the action verbs that we can draw out of it to design a system, to develop a system, to simulate the operation of a system, to deploy one, and then once it's deployed and it's working really well, maybe we can develop standards out of it. So one part of the IEEE is the standards activities, where the most famous example is the Wi-Fi standard was invented or produced in the IEEE. Similarly, there are many standards that have helped different parts of the industry to improve things like robustness, reliability, quality, safety, security of their systems in those industrial settings. Standards are the first step towards working towards a patent. So if you are inclined that way, then you can look at how to design and submit standards to the, IEEE. All right, so now this definition is a loaded piece of text, and it's not too conducive to understand where generative AI can be used to build new systems. So for that purpose, we will look at the specific topics of interest in the IES through the lens of technical committees or TCs. So technical committees are the areas of expertise of society, and most IEEE societies will have these technical committees. And the IES has about 24 or 25 technical committees, these dot points that you see on the slide. And I'm going to show you what the IES website looks like. So this is the website. I think you can see the browser as well. So if you go to thank you. Technical committees, you can see the committees are organized into clusters. It's the same list that I showed on the slide. And then you can go into each of these, and then you'll find information about the committee, the motivation and scope, members, activities, and so on. So if I scroll down here, we see that it looks at the full spectrum of the main subjects or domains of interest, and the composition of a technical committee and how do you join. So this joining a technical committee is free and highly encouraged. So you can, sometimes there is an automated form, like an online Google form, which needs to be filled in to become a member, or you can write to the chair. So usually a committee has 3 officers, the chair, the vice chair, and the secretary. So that's what it looks like. And you can write emails to them to join the committee. So since we are in the topic of the IES website, I'll show you a couple of other things. So these 2 links are quite important. Conferences are sort of for your light research. Publications is the preferred term in the IEEE. That publications actually means journals. So journals are for your more heavier, stronger contribution of research. And if you look at the publications, we have 3 flagship journals. Not 3, 5 flagship journals. And if you go into each of these, you'll find more information about the journals. So the impact factor, other metrics, and also the editors-in-chief and so on. This open access is another challenge opportunity, how you look at it, because I think the IEEE at scale wants to transition into open access at some point in the future. So this can become a challenge because open access is a fair bit of money, so $3,000 or $5,000 US. Then you could write to the journal, and they might waive the fee because of Sri Lanka's state as a developing country. You wouldn't be expected to pay the full open access fee. But journal publications are for a stronger, deeper technical contribution. If you haven't written a journal article before, then best to start with a conference. And there are many conferences sponsored by the IES. So it doesn't, usually the ICON attracts a large audience, so does the ISIE and the ICON, this one. But the other conferences are also good visibility for your research. So you could start with a smaller conference, maybe close to Sri Lanka. So that might be closer, or there might be others in Asia that are closer. So you could start at that point, so conferences, and then gradually progress into a journal publication. So some of these journals take a very long time to send out a decision. But it's not just the IES journals. I mean, there's so many other journals that you can pick from with good impact factor and publication track record. And then for membership activities, you would go into this, how to become a member, how to join a chapter, how to create a chapter, young professionals, women in IES, diversity and inclusion, and so on. Then under industry, so this is mainly for industry practitioners or even students, so staff who are looking at industry for different opportunities. How to be a speaker at an industry forum, different kinds of resources, and yeah, about the committee as well. If you look at the news section, there is the IES also has what's called the Industrial Electronics Technology News. That's a separate website. Yeah, here. So here you'll find different kinds of information, the new fellows, recent publications, and any other updates related to that looks familiar, interviews and seminars, webinars, and so on. So webinars are another opportunity. It's a thing similar to this. You can also, given your area of expertise, submit an expression of interest to conduct a webinar. You have to be an expert in that area. You have to have wide knowledge so that you make sure that the time of the audience is well spent attending that webinar. All right, so I could just go back to the website. There's also governance structure. So there's an administrative committee that meets twice a year to decide, or thrice a year to decide different kinds of activities, funding for different projects, and so on. And standing committees and so on, and elections as well. So if you've just become a member, then gradually you continue volunteering, and then you become more visible, and then you can apply to become an officer, and then follow through in that trajectory as well. So you can become an officer in the IES and an officer in the IEEE and so on. So usually there is the technical activities, the conferences, publications, and technical committees. Technical committees and conferences. There is the publications activity, membership activities, and industry activities. So that's usually how the menu is organized. And even if you go into any other website of another society, you would find this sort of delineation of their activities. Okay, so I go back to my slides. So these are the topics of interest. And now the most important question of this webinar is, how do we use generative AI to improve industrial electronics research, applications, practice, and so on? So I start with, I'm taking a few of the TCs, so smart grids is a TC, and I'm looking at how in the area of smart grids, how can we use generative AI? In this case, a text-based GPT to improve the outcomes of research. So what used to be that we would conduct several hours of a literature review, trying to figure out the answers to these questions. Now we can ask GPT directly, but of course we have to make sure that we fact check that information to make sure that it's current and valid and relevant. But this is an example in a smart grid setting. If someone was to use generative AI to hack into systems or launch cyber attacks, what does that attack look like? How does that change from a smart grid to a microgrid? What are 5 research questions on this topic? And for each of those questions, what are the ratings for these factors, scale of the smart grid, sophistication of generative AI attacks? So this way you're building out a bit of a structure for your research before you actually conduct the research, and that can be quite helpful in directing the research in the right towards the right objectives. So this is the second example of a SOC or system on a chip. So provide the general outline of an experimental setup for an ESOC. And how does this experimental setup vary for an aged care application? So we have a general experimental setup that is useful for you to conduct the experiments. And then the same in the same context, we can look at changes to this in an aged care application. And also finally, so increasing user participation when conducting field studies, because you want to evaluate the chip in realistic settings. How can we increase the end user participation? Okay, so next one is transport electrification. It's a very sought after, highly popular topic. This includes EVs, electric trains, buses, and so on. So in transport electrification, you wanted to evaluate a potential system that you built. You want to make sure it's socialized properly. Then this sort of question is useful for socioeconomic metrics for evaluating transportation electrification research, a step-by-step guide for implementing this scheme, and also distinguishing between metrics and current benchmarks for transport electrification evaluation. So you can see the different varieties of questions that we can ask about research or practice or application of a certain technology in an industrial electronic system or platform. And that way we can increase our knowledge and also increase the contribution of our research or application. So here, these examples are styled in that of an AI assistant, helping you to do your research. So if you've worked in a research team or even an industry practitioner team, then you have an AI assistant in addition to the human researchers in your team, which greatly improves the quality of the research and also the time taken to deliver that research. So design is another area, especially with the image or the multimodal type AI models. So just a few examples. Smart grid layout is the design that we require. You wouldn't be able to do any of these designs in the first prompt. There needs to be some context and lots of back and forth, which is now being called the AI workflow. Where you start with the skeleton and start filling it up with different parts of the answers provided. So in this case, a smart grid layout for transmission, control, and operation functions, but optimizing these. So where you push, where you construct or establish the transformers, where you include the cabling, how do you include the operation center? So that sort of layout can be quite optimized given the right types of prompts to make sure that the output of the design is good, reliable, and valid. The same goes for circuitry. So if it's system on a chip, For example, how can we optimize the location of circuitry or the integration of circuitry for space and energy usage so that there is no unnecessary energy expended. Then in a smart city infrastructure, how do we plan the roads, or how do we plan the bus stops or the train stops, and general crowd movement for increased safety, security, and sustainability metrics. And then designing a cyber physical system or factory automation for increased throughput. So you might give an image of the current factory layout and then ask GPT Vision or any other tool to redesign or revise this setup to make sure that we have increased throughput. So most likely the first few times it will get it wrong, but gradually to understand the types of queries that are coming from you, and then generally improve the quality of the output. Finally, the last one is the pathways for autonomous agent navigation in a controlled or uncontrolled environment. Okay, so that's generative AI. I just wanted to add a little bit of information about a different kind of AI that we are building in my research center. So this is small AI. So if you think of generative AI, billions of parameters, lots of computing, a lot of overheads to manage, to deploy, manage, and use it. So comparatively, there are other technologies being trialed. One such is called neuromorphic computing, so which is a computing approach inspired by the human brain that uses physical artificial neurons for computations. So most conventional computers have this von Neumann bottleneck, and neuromorphic computing will aim to resolve this, because the bottleneck is because of the CPU and the memory being separate, whereas with neuromorphic or spiking neural networks, all of that will be together because you're learning on the spike, on the signal. So FPGAs, analog deep learning, spiking neural networks, memristors, and vector symbolic architectures are some of the technologies for building this kind of small AI. And commercially available tools to limited parties. So True North was the first neuromorphic chip by IBM, Tianchik from Tsinghua University, Spinnaker from Manchester University, and then finally Loihi. So our collaboration is with Loihi, where we are working on building a small AI using neuromorphic computing. Then finally, we have an equally important topic, which is AI ethics. So von Neumann, the same guy, spoke about this in 55. Can we survive technology? Potentially, yes, but we need to act fast and act intelligently to avoid potential damages or dilemmas because of the misuse or mishandling of AI. So AI ethics is another broad topic. So AI ethics, for example, progress from the GDPR to the EU high-level expert groups framework, the IEEE ethically aligned design, and then now there's about 80 plus ethics frameworks. And the contradictory point of view there is that most of the technology providers, Google, Amazon, Facebook, have already published a responsible AI guidelines document and similar documents without wider consultation. So this is a challenge that the technical people, the engineers, the scientists, should not be charged with building the ethics policy or the ethics guidelines, because that has to come through wider consultations with people in other domains and disciplines, including potentially ethicists, to improve the quality and robustness of the conversation that's being had. So ethics has been transitioning from just AI ethics to responsible AI. So responsible AI can be described in multiple adjectives, if you like. So accountable, effective, explainable, ethical, inclusive, reliable, resilient, and so on. So on the right side, you see a responsible AI framework that we've recently proposed as part of a thesis of one of my students. So design to develop, to deploy, and then how responsible AI enables these responsible and generative AI, and how the ethics guidelines and ethically aligned design enable the responsible practice of AI. So it's a cascading effect upwards of building better systems that are more responsible and capable than the opposite of that. All right, so we're almost there. So how do we get started? There are many courses online. So if you are familiar with Karpathy, Andre Karpathy was, I think he's finished his PhD. Last time I checked, he was still doing his PhD, but he has worked in several of the key players, OpenAI, DeepMind, I think. And now he's resigned from all those jobs, and he just creates tutorials for anyone who's interested. So this one's really good. It's highly rated. I highly recommend it. And it talks about building neural networks from scratch. So if you have the time and the energy and the interest, I highly recommend following one of these to make sure that you are on top of the technology itself. Deep learning AI is also good. This is by Andrew Ng, so one of the seminal people in the space of AI or recent AI. And there's many courses in there as well. So specializations, courses, short courses. So even Andrew Ng has transitioned from conducting research into training people to use AI. There's also no shortage of newsletters. I find these quite useful. So the batch, there's a Nature is the best journal in the world. So Nature also has a newsletter called Nature Briefing. So you just have to submit your email address to subscribe to this, including Neuron. And Ethan Mollick is a highly capable and interesting person to follow in relation to AI on LinkedIn. So if you're not following him, you should start following him. He also has a Substack where he writes about the different challenges he faces. The other one is Import AI, also just talks more generally about the recent developments in AI. All right, so timely, I think. So we started with AI definitions, distinguishing conventional AI and generative AI. And then we looked at the capabilities of AI, so prediction, classification, association, optimization. And then I presented the AI lifecycle so that potentially if you start building AI, you can find this lifecycle useful, or the information in the different phases of the lifecycle. And then we switched entirely to generative AI with some examples in healthcare. And then we looked at how to access a generative AI model. We looked at some generative AI examples in the mainstream healthcare, education, and so on. And then we transition into the topics of interest, which is based on the IES definitions on the website. And then we looked at how some of those topics of interest can be improved or augmented using generative AI capabilities. And then finally, I wrapped up with some links for further learning so you can get started as soon as possible. So on that note, the content I prepared for the webinar ends there. And I'm happy to take questions, or Upul, over to you.
Right. Thank you so much, Professor, for the wonderful session that we had. So it's all up to you now. I think you can ask questions straight from the professor, or maybe if you have having issues with your audio, you can just type your question in the chat box. In the meantime, let me just ask like a couple of questions that I had. Like one was behind the motivation about this ICT cluster in industrial electronics, professor. Like so even for me, when I joined IES, like I mean, not just for me. Usually, when people think about industrial electronic society, people think of sensors, machines, and control systems like smart cities and systems on chip and all. So then, what was the motivation behind the ICT clustering, including the web and information the technical committee?
Yeah, a good question. Thanks, Upul. So I think the motivation is to the motivation is to firstly acknowledge that an industrial system has a fairly strong or important digital technology component. And if you think of the best example for an industrial system is an energy system, and there's a lot of data generated. There's a lot of technology used in such systems, and this is one of the reasons that an industrial electronic system or solution does not exist independent of the digital technology or the ICT technology or ICT. That was one of the reasons. And the other one is that the IES wants to be more multidisciplinary, where it's not limited to the sensors or the chips or the instrumentation, but it takes into account that there can be sensors. So IoT is a good example. The IoT is attached to the platform that computes or aggregates even, and then there is data generated. So if you think of just the IoT, potentially the application and the research is limited. But if you think of an IoT platform and IoT system, then there's an opportunity for more applications, more value, really, finally. So these are the reasons. And then recently there is a strong push for a new technical committee in AI. And so that's also happening, and that acknowledges the growth of the expansion of AI into what it is today. So yeah, these are the reasons for this inclusion.
Yeah, thank you. So also like what are the opportunities for collaboration within IES that you see for, or specifically for Sri Lanka section members?
Yeah, I think so. This is generally a challenge for most chapters, is to collaborate with other chapters, because everyone's sort of busy, not so much time for the volunteering activities. But I think if you start with a proposal of a joint project, so the technical committees are potentially the easiest first step to become more visible. So from the chapter, you present a proposal to a technical committee, and technical committees also have some funding, and they might allocate it to the chapter to build this out. If it is if it is a technical system, or if it is some kind of solution that you are intending, but they will want a well-defined project proposal that delivers this. So this is from a technical activities perspective, but if you think of membership activities, there should be lots of funding for the promotion of the society. So one challenge there is the promotion, and the increase in membership has to be sustainable. So sometimes there is free membership. So you have a spike of the number of new members, and then the next year it drops to the previous year, the level of the previous year. So that maintaining that same level of interest, or sustaining the number of new members, is a bit of a challenge, and that's where you can propose maybe not with with decent amounts of funding, not excessive, a 3-year plan to increase chapter membership to a certain level, and this can, as part of this plan, there can be technical activities, educational activities, industry activities. So you look at the key areas as I showed on the website. So there is the journals, the conferences, and the industry activities. You look at what has been happening in the past, and then you integrate some of those into your proposal. So the technical committees would be a good starting point, but also you can write straight to the one of the vice presidents. So for example, the membership vice president is quite active. He's also active in the IEEE. I think there's a chapter delegate. So they will respond. I know Antonio will respond to most emails. So maybe that's one of the best places to start with a proposal.
Yeah, so yeah, that's quite good, nice. Like as you said, yeah, Professor Antonio. I mean, like I used to work with him in the one of the IEEE MGA committees back in 2018. So we were kind of known to each other. He was really helpful throughout like
Yeah, nice.
yeah.
Mm.
So yeah, as you said, like he is definitely indeed a very helpful person. And then and given that like he has a like major role in IEEE itself, I think he will be the upcoming VP of MGA itself. So he has a better power and like opportunity.
Yeah. He
Akila,
has,
right.
He might be a president also, so good
Right,
to
right.
keep
Yeah, that's the path is going on. Like there is a high chance of getting a presidentship for a VP MCA. So that's what we are doing. So
exactly.
Akila is our Dr. Akila is our vice chair, and she's the chair of IEEE PEST Sri Lanka chapter as well. So and then she's the newsletter coordinator of IEEE Region 10 as well. So she's a like passionate volunteer. Akila, you want to raise something?
Yeah, thank you very much, Professor. But my question is technical, not related to IEEE. Thank you very much for the experience shared, and we'll make sure IES chapter, and as you said, the collaborative events will help us to get more visibility and do some more impactful events. So my question is a kind of a opinion from your side for ethics in AI. So it needs like every discipline to be on board for this, I believe, like for someone who is using this for any other applications, maybe not for only for robotics, power or anything, but in general public. How do you think where we are at the ethics of AI and also regulations we have prepared? So is there a huge gap, or is it like in a good standard now?
Yeah, thanks, Akila. So the strongest ethics or the strongest responsible practice of AI is pushed by the European Union or the European Parliament. So they have an AI Act, which I think they enacted. It was passed. It became law late last year, and it classifies AI in terms of risk, so high risk, medium, low, and non-classified. So things like social credit systems and weaponization of AI, those are high risk. Facial detection is still like medium risk with the right controls that is encouraged. So this way they have given some examples of the different kinds of AI and the level of regulation required. And this will become evident in most of the European Union countries. So that's the strongest regulation so far. But not many of the other countries have been receptive, and that's partly because they don't want to stunt the performance or the innovation from the private sector largely, maybe because they get political donations or whatever. That is one of the reasons, and the other reason is that they don't know how to navigate this space. So without regulation, usually what governments and large organizations do is they resolve to guidelines, so responsible AI guidelines, which are non-committal or ethics guidelines. The guidelines are maybe a 2018 sort of discussion or compilation, and there are many companies as well who've provided these guidelines. So if you think of the big five, Google, Amazon, Facebook, Meta AI, all of them have different kinds of guidelines, but that should not be the case as well, because you don't want the technicians, the engineers, the scientists to come up with the ethics guidelines, because we already have a biased view. We want to build the best classifier or the best predictor, the best performance, and this itself is a challenge. So that's why we need a broader conversation. And places like the European Parliament, they bring lots of different experts, and they bring people who are maybe even people at aged care facilities who will be receivers of the kinds of AI. And then you don't have consensus. You have a lot of disagreement. It doesn't move forward. So these are some of the challenges. But generally speaking, I think it's the European Union regulation is a good place. It's a good starting point. And then the other ethics guidelines are a good initiative from the organizations to show that we are all interested in regulating or managing the risks.
Thank you very much, and it is informative. Like as you are mentioning, I got the information about this, and we'll read on that. I believe there is a research gap also that we can give more inputs on that area.
Yeah, definitely. Yeah. So any industrial or power electronic system, there's definitely a gap in terms of the ethics perspective or the ethics practice. And that can be published easily, or most conferences, journals will be receptive to that kind of content.
Thank you very much. Thank you.
Thank you.
Yeah. So yeah, we have like I see that. Yeah, so I was just waiting for Professor Kamal to respond. Like, thank you very much, Professor Kamal, for joining us tonight. Yeah. Please, raise your voice.
Thank you, guys, for the most active chapter ever I've seen. Very interesting, and thank you, Daswin, for your beautiful presentation. I missed part of it because I was sleeping. I missed part of it, and I came to the end of the presentation. So unfortunately, I missed it. But everybody has the chance to go to the website, as you said, and look at, so even the chapter can announce this and put the link to the website where people or probably the chapter can advertise on the website, where if anyone goes and see your presentation, they have to learn about the chapter, who is the organizer of this event, and so on. So it's a good idea to make publicity for the chapter. Yes, so I'm connecting to you guys for two reasons. The first reason is I wanted to hear Daswin speaking. I never heard him speaking technically. I also heard him speaking politically and socially during IES event. So it was a pleasure to see him. And also, I want to connect with you guys in India. You are in India, is it?
This is Sri Lanka chapter.
Yeah, in Sri Lanka, yes, chapter.
It's very, we are neighbors of India. Yeah.
Yes. So I wanted to connect with you and see how things going also in this part of the world. So we are far away. We are in the North America, and you are in the South and the East continent. So we are 180 degrees almost.
Yes, absolutely. Yeah.
And since I'm very much involved in IEEE as well, I'm division director, where IES is one of the sites that I am taking care of.
Right.
So we wanted to have the feedback of all the chapters, encourage you and everything, and I am also member of the IES Finance Committee. So if you have good ideas as a chapter, we have money, we can support your activities. You can be the flag holder for any new initiatives, whether it comes through a technical committee or as a chapter, or if you want to do some technical activity, regional technical activity, or humanitarian technical activity, or anything related if you are interested in AI, for example, like what Daswin is presented, and you have a good idea about starting a new kind of activities based on AI to promote AI or to make AI awareness to the population, AI awareness or something like what Akila was asking question about the rules, regulation, and so on, because not only people need to be aware of what's going on, but also politicians need to be more aware because they don't know nothing. So those people, they are really as a low pass filter. They have no idea what's going on. So they need to learn. And their learning curve is very, it's like 10 degrees. It's not 70 degrees, the learning slope. So
Right.
you can conduct these kind of activities also. And one other area, what I missed the presentation of Daswin, and here comes to my question that the energy sector is extremely neurologic sector and strategic sector for everyone, and people are wondering how AI can help in making this sector attack free, you know, to have a kind of peace. It's like imagine like your bank account, you are always worried about your bank account being robbed by someone at any minute. You know, if you put your card to pay and then you say, oh, there's no more money or whatever. So the energy sector, we are living now in this kind of area. So we are somehow worried about are we gonna have in a crucial moment the energy, the light can turn on and we can still have the heat and so on in difficult times. So, and here comes the question of security and of these energy sectors. So I don't know how AI, Daswin, according to your research and so on, will AI enhance really the security of this sector? Can we count? Can we involve AI in all these at all these stages level and the security from the field up to the supervisor controller? This is the question. I don't
Thanks.
wanna mobilize the discussion with the chapter, the brilliant student in the chapter, but it's, this is the idea.
Thanks, Kamal. Nice to see you. So I think, yeah, it's a definitive yes. There's a lot of potential in AI in securing what you just described, so critical infrastructure, starting from the poles and the wires to the transmission to the generation. And also in the case of an incident or event of large proportions, then managing the triaging really, the challenge of supplying or reactivating the grid afterwards. So protecting or preventing attacks, protection of the grid, and also reactivating the grid. So we can think of AI as being capable of supporting the human operators in all three scenarios, both generative AI and the conventional AI. And there is some research in even in the IES journals, some research in the conferences, but this is an emerging area, and these are mission critical systems that need to be protected.
Thank you. Thank you.
Thank you.
I am also looking for an excellent students for PhD with industry work. If you guys, someone of you are interested in doing some research on I have a new project on probably the use of AI in detecting faults for large hydro generators, like 100 megawatt, 200 megawatt, 300. We have the biggest one, 360 megawatt, and we have so many problems that can occur in those generators. So we wanted to develop AI-based system to make them preventive maintenance for all these huge units. So this is one of the subject. If anyone is interested, please send me an email, or I will be happy to look at your file and present it to the company. Thank you.
Thank you.